We left off talking about this whole idea behind excited and ground states. What did we talk about the ground state? What's happening in terms of the electron?
It's where it's comfortable at.
Where it's comfortable at, it's where it's normally found. Okay, so they're just chilling. It's where they're normally found out. From there, it goes to the excited state. How is it possible for it to go to the excited state? Gains energy. But if it ever wants to go back to the ground state, what must it do? And what can we get that energy off as? Okay. Okay.
This didn't have to be weird. It didn't have to be.
Isn't it electron voltage?
I'm just confused. Why'd you come back?
She left your stuff in here, I think.
Alright, anyway. That's the unit. But what can we get that energy off in as it goes from the excited state to the ground state? Photons. So right here is a perfect little demonstration. I need to show you a certain one first. You guys have seen this before. First pick. So these here are cathode tubes. Inside it is a certain gas. In one of them there is, yes. Shh, don't tell the fire marshal. You guys have seen this before, so this is what I'm going to do. I'm going to run an electrical current through this. So the electrical current is adding energy to the situation. So there's atoms in here. What we're going to do, we're going to excite those electrons in that atom. But whenever it comes back to the ground state, what are we going to see?
It goes still again.
No. As excited electrons go to ground state, what do we see?
It slowly goes away.
A red light.
You guys have seen this before. What is this called?
Red light.
It's not an incubator.
It's what you want to end up with.
No. It's a special type of sign. They're all in Vegas. Neon signs. In this case, this is what they do. They literally have a gas in here. So inside this cathode tube, this is actually neon. And so what's happening, we're running this electrical current. It's exciting these electrons in here, those electrons, those atoms, to excited states. And when it comes back to the ground state, we see light. So you can do this with multiple different ones, multiple different types that you find this with. So I'll be careful as I get one. There is neon. Here is
Harmful gas.
oh yeah, this actually is the one that's harmful.
So if that shattered, would we all have to like run out?
No, but I'd probably end up with cancer in my 60s. This right here is really pretty. It's one of my favorite colors.
Light blue.
Is that kind of like a black light? Like, can you see like?
No, this is not black light. Same premise as what black lights do. Like whenever they like, you put a black light on something, and it makes something glow. Yeah, but that's
Why does it look two different colors?
because up here you're getting a whole light together, and it can spread apart in different parts. In these, what you guys will see is there's two different types of spectrums that these have. For example, this is mercury vapor. So in it, there's an absorption spectrum and a transmitting spectrum. What the color we're seeing is the color that it's letting off. That is not the color it absorbs. So it lets it off. So the combination of all the colors that it's letting off, we see this pretty, I'm going to call it a light blue. Some girl in here probably has some fancy name for it.
The blue light.
Yeah. So in this, what can actually be done is this light can be took and can be broke apart. Have you ever wondered how we have never visited a planet, but we can tell you what's there? What elements it's made out of, what you can find there? How's that possible?
But how's the sound coming?
Because of what?
Sound.
Satellites help, but the whole
On
premise,
the inside of it.
the whole premise behind it is what we're doing right here. What's this one? Oh yeah, I haven't showed you guys this one. This one's the most common gas in our atmosphere.
Ooh.
This one is nitrogen, so you guys can see that.
When the sun's like setting, turns like kind of pink. That's what it makes me think of.
So now y'all can gather around. We're going to stage a picture, make it look like y'all being scientific and looking at things so that we can put stuff on the county page.
Can we get like
Molly, come get a picture.
the picture we're taking? Duh. Are we smiling or are we just gonna look at it?
You're just going to look at it. Hold this and look into it like you're looking at something. Hold this and look into it like you're looking at it. You're looking at this one. Put it up to your eye. There you go.
Say cheese.
She's like so different. Here, you try it.
Chemistry.
what?
Try it. Look through it.
I don't know what
You're not going to see nothing major. Okay?
Just see a rainbow.
And
I
that's the
see that
problem.
orange part right there.
Yeah, but that's the problems. I'm going to show you here in a second since the fire marshal has came to my room and hopefully he's not coming back. Oh, that was a little hot. Ah, it's hot. Alright, here is the one I actually did what I'm going to talk to you guys about. I did this with this one in college. This one's really pretty, you ready?
The colors changed.
Alright, so in this, you absolutely see colors change.
But earlier it was like rainbow. Now it's what little colors do you see in that?
But in this, what you're seeing is the effects of what we were talking about, okay? Now in this whole unit, what we're caring about is where these electrons are at. And we're going to keep going with these and what's happening with these electrons. So, this is how we can identify what's on a planet, what's in the atmosphere, is we can literally take the light. We have fancy telescopes
They're just that tall.
that take in the light coming from the planet and breaks it apart into what we call a line emission spectrum. And I'm going to show you all that up there. You're really not seeing nothing fancy, guys. I mean,
It's so cool.
I'm talking about those. They're honestly junk. So, everyone can go grab a seat,
Can I go use that? Do you have to bring it back?
sign out, take the hall pass.
Oh my God, look at this back.
I have college stuff on. Come on, Molly.
I haven't taken a picture all day because
Molly, can you get down?
Molly,
so I can get
go
down?
take a picture.
What if I would fail?
If you're watching video, close your eyes.
In my suit.
I didn't take a picture earlier.
I'm really feeling good about this.
Cool.
He gives like a 2 out of
Look, 2 out of 50 was flat. I'm going to get at least a 5.
Alright, so in this, somebody can flip the light switch back on.
Mr. Hall, can I see Hannah Massey, please?
Yep.
Thank you.
No, it's not right.
My baseball shot's
Yep. Did get that one. Or is it the other one?
I don't even know who that is. Mikey, there's no way you meant to say who the person that is and you messed it up that bad.
I promise you, I'll tell you who I put on there. Well, I can say it out loud because
Oh my sweet God, Mikey.
it's bad.
Yeah, but that's bad.
I'm telling you, I can't spell. Crap. Have you seen his name?
I have.
Look, I thought I suck at English. Hey, listen to this.
Alright, so from here, this is what we're looking at. I want to show you what we're talking about. So, I'm going to look at my pictures. Alright. This right here is what I'm talking about within this. So that hydrogen light was the last one I showed you. So this is what we're looking at. Up here at the top, this is the absorption spectrum. This is the color of light that it will actually absorb and take in. This is the emission spectrum that I'm talking about, the light that it will let out. This emission spectrum is literally like your thumbprint. Everybody in here has their own thumbprint, and it's the same thing for every one of these elements. Every one of them has their own thumbprint in terms of these emission spectrums. So we can take this light, look at this emission spectrum, do the calculations, and we're looking and say, oh, hot diggity dog, that's got to be hydrogen, yo. So then we can look and say, this planet has hydrogen in its atmosphere. Somebody, yeah, I just don't even care. Okay. It's like, huh?
Maybe you'll get excited.
We'll play Space Desk.
Yeah, my shot's kicking in.
Oh, hey, anyway, so that's like, that's what you're looking at.
Mr. Hall, can I go to that now?
Yes. Alright, so in this, it brings us into a very, very interesting conversation. Very, very interesting day. About to experience some turbulence. You got to be kidding me. That's what you got out of my class for?
Yeah.
You didn't even bring me anything? Ridiculous.
That's what he was a basketball class for. You can bring them back. They're out strong.
That's right.
How long will it take to grade that?
Well, that's probably going to be graded in our 7th period because I'm going to try and find me a hiding spot to stay away so that I don't get bothered by anybody.
I just want to
Nothing against the kids, but it's like I've had enough of being the tech guy for a week. I gotta be honest. I'm ready for a break. So I'm hiding away. Alright, so in this we're gonna jump into something that is monumental, okay? Brings the foundation of what we're talking about here. In this situation, we're talking all about the electrons now. That's all we're caring about. And within this, we care about where they are, how they're acting, what's happening to them. So in this case, we're going to start in on something, and I need a favor of you. It does not matter how we start. Either way we start in this unit, there's 2 more subjects, concepts that I got covered in this unit. And in order for me to get it really covered, the best way is to start with the electron configurations and then break it into the quantum numbers. So I need you to do me a favor. I need you just to accept the fact that I'm saying there's such thing as quantum numbers and they exist. And I need you to just accept the fact of some things that I tell you, just accept it at the moment. Because either way it goes, you're going to get confused. Either way we go around this. And if you combine these 2 things together, you lose everybody completely and it's a train wreck. In this, I just need you to accept some things. I would rather you be interested in where I'm getting certain numbers from, certain symbols from, so that when we go to the quantum numbers, you're all like, oh, that's where that came from, and we're good, instead of vice versa. This is what I found out in years of teaching, that this is the best way of doing it. So, do you agree that you will just accept some things that I say accept?
Yeah.
Fantastic, thank you. Mike, you said yes.
Yes.
Of course you'd say no. I will be giving you a new periodic table at a later time, but not right now. So in this, we're going to start talking about electron configuration. So whenever we want to talk about electron configurations, the key to this is we care where the electron is. Care about where this electron is at. And so within this, these are based off of the 4 quantum numbers, but we haven't jumped into that yet, so I'm not going to stress those to you.
I'm not done. I'm just.
Thank you.
Yep.
And within this, I'm going to be openly honest with you. There's 3 different types of configurations that we can do. Alright, so the first one is the one that we're going to drive home at first. This is the one we'll start with because it's the more complex, more detailed one. And then as we break it into the other 2, it gets more simpler as we go. The first one is what we call orbital notation. I'll show you all about this, what it's like, what it's about. Got a big pick. It's not going to be both, it's one or the other. So orbital notation is what we start with. From there we go into the second one. Please do not get confused. I know at first you're going to say, wait, Mr. Hall, that doesn't make sense. Because the second one is what we call electron. That is a horrible, it looks like a Greek letter.
Probably looks like Mikey's head.
Ouch. Electron configuration. So in this, you got the electron configuration, and then the third and last one, this is when everything becomes very simplistic and easy.
Was not expecting it to be that loud.
I thought you were like throwing up.
And the third one of these is the simplest one, noble gas configuration. The third one is absolutely the most simplistic. As you go through these, they get a lot more simpler and easier as you go. But now within this, you need to understand that there's 3 rules that govern and decide how you're going to do these. No matter which one of the 3 you choose, they follow these 3 rules. They will not break these 3 rules. First one is the off-ball principle. Second one is the Pauli exclusion principle, and the third one is Hund's rule. And I'm going to tell you right now, if you want to see somebody that is in the running for the most ugliest man on the face of the planet, look up Wolfgang Pauli. You look at that man and go, whoo, wow.
Gotta look it up right now.
That's bullying, Mr. Hall.
He's dead.
And
No
then,
matter.
Wow.
Bullying's okay. You'll look at that.
Yeah.
Question mark.
They don't care. They're
He's
called
not bad looking.
Wolfgang
I
Pauli.
mean, he ain't sexy, but
He literally looks like a
His
toad in the
face
face.
just matches together.
Oh, that's cold.
Matches.
He looks like a toad. Okay?
Everybody wants
Mr.
to
Hall, I
know
don't
what
want
roasting
You do realize you're insulting someone on camera, right?
He's dead.
He's a hungry.
God.
Alright, so in this,
Oh, he was cute when he was yours.
wow, okay. So anyway, in this, breaking off these three, there's something you gotta learn with these periodic tables. So I'm gonna show you.
All you didn't say.
What? Close enough. Alright, so in this, you have to understand the periodic table can be broken down in multiple different ways. In this way, it breaks down into 4 blocks. Okay, I kind of feel like I'm talking about prison whenever I'm talking about this. So within it, you need to understand and know where you can find the different blocks at. So the first one is the S block. The S block is the first 2 columns off the periodic table. Remember, columns are vertical, up and down. So here is the S block. From here, I'm going to go on and jump on over. Going from the first 2 columns, you can break it into the columns 13 through 18. These guys are the P block. Now you don't know what this S, P, D, and F, B and F's next to are, but these are just referring to like orbitals. You're going to hear about that. Remember me telling you whenever we started this, just accept something, accept an orbital right now. From here, we have the lovely columns 3 through 12. Is the D block. And then the very last one, if you ever wondered why these two just stick down here by themselves, these guys down here are the F block. So within these, yep, these are the different blocks, and it's important you know these different blocks because that's where these letters are going to come from that I'm going to show you. So within these, the first thing we're going to talk about is the off-ball principle.
Casey, your phone's falling out.
You're welcome. Alright, so in this, the off-ball principle is a fundamental principle.
Why is it not spelled O-F-F-B-A-L-L?
Because the guy that came up with it, that's how his name is spelled, and he's a very special dude. So this is what the off-ball principle states. Put in simplistic terms, is an electron will occupy the lowest energy level within that. Remember what those energy levels are. We showed them to you before. That's N equals 1, N equals 2, all that stuff. Okay? Those energy will occupy the lowest energy level that can hold it. The best way to explain this to you as I can is electrons are nothing like you. Electrons are the laziest things on the face of the planet. Let me preface this with when I say they're the laziest thing on the face of the planet, I'm being sarcastic. They're not like human beings. They don't have emotions or anything. I'm just trying to get you to connect with this. They are lazy. They do not want to do anything. They are the laziest thing on the face of the planet. For example, if we had a bus that had 56 seats on it, and we were loading up to take a trip with this class, there's not 56 students in here, but if we were loading on the bus to go on a field trip, where would you all run to sit?
The back.
The back. Why? Because y'all like, I'm not sitting in the front where Mr. Hall's going to be, because I know he's going to be up there, and I don't want nothing to do with Mr. Hall. Forget it. Electrons are completely the opposite. If every one of those bus seats is an energy level, they get on there, if that electron boards the bus before I do, it's going to take the first seat. And when he takes the first seat, he's going to look at me when I get on the bus and say, tough luck. I don't care. Move on, Mr. Hall. You snooze, you lose. This is my seat. They're lazy. They'll occupy the lowest energy level. So remember, the key to this, lowest energy level. Alright? Y'all doing okay?
No.
If you're wanting to bring cans in for this class and you want it on your report card, it has to be to me before first period.
Huh? Tomorrow?
Yes.
Thank God. My mom's about to kill me out of 48.
You say tomorrow?
Yeah, tomorrow morning before first period. When first period starts, somewhere during first period, I'm submitting my grades. I have no idea how that is going to affect your grade. I don't know how many points are in the class. I know that's worth 70 points.
Well, I know as long as
Well, I got a 13 out of 70 and it brought me down 18%, so.
I got a 31 out of 70.
I'm not laughing at you, Kaylee. It's the way you say it.
Alright, so in this is the important thing with off-boss principle. It gives you the field order. The field order is literally the order in which these electrons will fill up these orbitals. There's two separate ways to find your field order. I'm going to show you both of them. The first one I show you, I hate. I despise it. I think it is completely horrific. I hate it. And I do not use it. But I show it to you because if it makes it simpler for you and you can remember it and memorize it, then hallelujah, thank you Jesus, we're going to use it. I'm going to use the periodic table though because what do I always give you on a quiz?
Periodic table.
Periodic table, except for the element test.
How long is that away? Please
Little
tell me
ways
the
off.
second semester.
Can I take a picture of them?
No, it'd be in the first semester.
Oh. Well,
Yes,
we
it
got
is.
well, we got we got somewhere within 9 weeks to study for it, I guess.
Huh?
We got somewhere
So
within
you're
9
gonna be here first thing tomorrow morning before first period.
What if I bring it to you like after Miss Harrison writes my note? First period, beginning of the class.
I'll wait till the end of first period.
Thank
Second
you.
period,
Yeah.
grades will be submitted. Second period.
Okay.
Oh.
I think most of us have
We'll make
been.
Miss
So if I
Harrison
bring
run
in
a note.
6, you can't.
You get 30 points.
No, I'm talking about anatomy and
You
chemistry.
get 30 for chemistry, 30 for anatomy.
You do realize.
All you
Um,
have to do is bring
What?
first
Speaking
period.
of
Does she
anatomy,
bring
is
in
that,
30
is our
points and work for both?
No.
Yeah, he just.
Mr. Hall, is that quiz going on our anatomy for this number?
Please God, no.
No. Please.
Thank you, thank you, thank you. You are a lifesaver.
Alright, anyway, can we now get back to the chemistry? Thank you. So in this, you got to learn the field order first. So within this is how you start. So the important thing of it is S starts with 1, P starts at 2, D starts at 3, and F starts at 4. S will go 1 to 7, P will go 2 to 7, D will go 3 to 6, and F will go 4 to 5. Now within this, you're going to make columns, okay? And it's going to have the number and the symbol for it. So in this case, you're going to start with a column. We're going to start with an S column. So there are 1S, 2S, 3S, 4S, 5S, 6S, 7S. If you're feeling like you're confused right now, there is hope. This is new.
You said that.
You know, I promise you, this is one of those things that you don't get it at first, but then you start getting it, and once you get it, you're like, oh my gosh, can we please take a quiz like right now?
I don't think I've ever seen that. Just got it 2 out of 7.
I don't think it's gonna be 1P, 2P.
Starts at 2P.
Oh, what?
Okay, remember, always remember, 2P or not to P, that is the question. 3P, 4P, 5P, 6P, 7P. P.
What's the chia plant?
All right, from here, we go to the D. Where does D start? 3, so go to the third row. 3D, 4D, 5D, 6D. And you stop.
You have to do it like third, second, third, fourth row.
Accidentally
If you're going to use this method, it has to be done like this.
put P2. Is that wrong?
Yes.
Can I borrow your wine out?
So your number always has to be hers.
Always.
Call it Lee.
I know. Got it.
That's it.
From here, you go to the F. Where does F start?
Aaron.
So 4F, 5F. That's what you do. This is how you set this up. And this is why kids really like to use this one. You get the periodic table, you flip it over, you start writing this down. Even though the second method uses the periodic table, and it's right on the front already there for you. So in this, we're going to continue with it, breaking it down. So here's your fill order. I'm going to tell you, I'm going to take your fill order all the way across. I'm just going to go from left to right. It does not go under Pauli exclusion principle or Hund's rule. This is just like your paper being continued on. So in this, you will take and you will draw arrows through all of these. And as the arrows travel, you go from the back of the arrow to the front of the arrow, it tells you the fill order. So in this case, you will start with 1S.
It's diagonal.
It's going to go diagonal.
Trust me, I ain't nothing far up back here. Sorry.
From there, next one that's not been touched, the 2S. And then we'll go, this is why I don't like this, 2P and 3S.
Yeah, I'm not a favorite.
Honey, I'll buy good.
From there, you go 3P, 4S. This is where things change is after the 4S.
Oh, cool.
Wow, really?
No.
Don't change it if it ain't broke.
Facts.
3D, 4P, 5S.
Well, I thought that
Same difference.
I'm done.
Then from here, just keep going with it. 4D, 5P, 6S. 4D, 5P, 6S.
I'm gonna put it down.
Then from here, this is where things get freaky. Start here at the F's. 4F, 5D, 6P, 7S. One, two, two, three, three, four, three, four, changes path. It's different. 4F, 5D, 6P, 7F. And then last, bringing up the rear, 5F, 6D, 7P. 5F, 6D, 7P. There is your field order. These are how these electrons will feel. This is the first method. I don't like the first method. I'll be honest with you. I like the second method. Second method uses a handy-dandy periodic table. Yes?
Is the field order always going to be that?
Yes, it's always that.
So you can just memorize it?
Yeah, sure, go right ahead. It's not good for you to try to memorize something. If you can learn a system to break it down to get to it, it's better for you. You can memorize it. I've done it so long it's just a memory. Because to me, I always remember after 4S, I go to 3D. And then it always increases in enters level. 3D, 4P. Then you go down to where it's 6S. You jump from 6S to 4F, 5D, 6P, 7S. In this is the key though. If you're going to use this, the method 2 is with the periodic table. Before we go over there, you have to find these numbers. Okay, to get the letter, it's just the block that you're in. Okay, but from there to get the number that goes before it. For S, number equals row. The row off the periodic table is the row that you use. For P, the number equals the row. For D, it changes. The number, and I know I said we weren't going to do math in this, okay? If you struggle with this math here, come see me later on because I think we need to see a counselor to think about getting you out of chemistry. Row minus 1.
Oh, that's it.
And then F, the number equals row minus 2.
I thought this was the third hardest thing you taught.
It is.
It's easy. So far.
This part is. Alright, so from there, I'm going to show you the periodic table. You got the field order up there. I'm not going to write the field order back down again.
You're giving this videos trouble.
I'm giving you entertainment as you watch. Alright, so here we go. Are y'all ready? I'm going to show you my favorite method.
I don't think you're on it.
Alright, so in this, you got your handy dandy periodic table. I will give you one of these so that you can find it. I use this like a road map. It's literally how I do it. It's the row that I'm going through and the block that I'm in. So in this case, helium in this case isn't over on the right. It's right next to hydrogen whenever you're breaking this down. So in this, what row is this? So 1, 2, 3, 4, 5, 6, 7. These down here are 6 and 7 because look at these numbers and where they intercede at. So in this case, let's find our field order using the periodic table. What row are we in? 1, and what block do I go through? What block do I go through?
S.
S. So 1S. After that, where do I go?
2S.
2S. Second row, S block. What's this one?
2D. Wait, hold on.
That's P.
Yeah.
2P. Why is it 2P? Where's the P block? 13 through 18. The D block is 3 through 12. So what row are you in?
What are we on?
Don't look up there. Look here. Don't worry about that. Look here.
3.
What row are we on?
3.
Right here where the red line is. We just went through.
There's several red lines.
This.
2.
You're in second row. Which block did you just go through?
P.
P. So 2P. From here, what row?
3.
Block S. So 3. What's this? Because it's the S block.
Why do you need to know?
It's the field order. It's how these electrons feel. From there, you got 3P. From here, fourth row, S is 4S. Then you pop here in the D block. How do you get the number for the D block?
The row minus 1.
To row minus 1. Thank you. So what row am I in?
4.
Minus 1 is 3. What block?
D.
So 3D. Then you come over here. What row? 4, but I'm in the P. So what is it? 4P. Then you go 5S. Then you go
4D.
4D. Then you go 5P. Then we go.
6S.
Then you drop. Notice the number. 57 through 70. There's 57 through 70. That's F. So subtract 2 from the row. So from here you get 4F. Then you pop back up.
Okay, I get it.
5D.
I get it.
6P. 7F. 89, you drop back down. 5F. 6D. 7P. Done.
I never